So the best thing for us to do is try to figure out where can I get 0. So is there a way to make this component 0? When y is equal to what? 1. So if when y is equal to 1, that 0 squared times whatever doesn't matter. So I'm going to look and see when y is equal to 1, my slope is going to be 0. So I'm going to go to my 1 and say my horizontal slope right here. And if you want to write on here, that's a horizontal asymptote. That would be wonderful. And then because I'm thinking ahead, I want you to draw me 2, maybe just 1. So here I have it at 0 pi, and the value is 1 comma 0. And we'll be working with 1 since we're looking at cosine. And here I have 1 pi, and that's going to be what comma 0? Negative 1, because I went to the left. So let's make our number line, not number line, t-chart. So I'm going to make double t-chart. And make more room on the right side because I'm going to be plugging certain things in. Here's my x and y. So we're plugging it in 1, 2, 3, 4, 5, 6 times. Let's start with the 0, 0. When I plug in the 0 into my y, we get negative 1 all squared is positive 1. Is everyone okay with that? Yes. Then I have cosine, and when I plug in 0, we get 0 pi. And at cosine 0 pi, what number do I have? So that means my slope is 1. So let's make our slope. Again, we're simply sketching. If it's too steep or not too steep, that's okay, as long as it's going positive. And then let's go to 0, 1. Well, let's do 0, negative 1. Let's attack all the vertical pieces. So here I have, if I plug in negative 1, that's technically negative 2 all squared, which gives me 4. And again, didn't we already say cosine of 0 pi was already 1? So we have 4 times 1 is 4. So at this point, it's pretty steep. It's almost vertical, I guess. Kind of. Mine looks about the same. Let's do negative 1, 0. So when I plug in the 0 into my y component, it's simply 1. And then for the next piece, we have cosine of negative pi. Now, cosine of negative pi. If I go this way, it's pi. If I go the other way, still negative pi. So this is technically also negative 1 pi. So that's going to give me negative 1. So I get negative 1. And that point is at negative 1, 0. So we're going to go down. And then let's test, which one do we not test? Negative 1, negative 1? We didn't test the positive one, silly. So we have, when I do negative 1 all squared, it's going to be 4. Cosine of negative pi. So that's going to give us what? Negative 4. What's that?
Where'd the 4 come from?
When I plug in negative 1 into this guy here, we get negative 1 minus 1 is negative 2. Negative 2 all squared is 4. So this one is right here. It's going to be negative 4, pretty steep, going down. And I forgot to test 1, 0. So we have 1 cosine of pi. And cosine of pi is 1. Oh, negative 1. So we get negative 1. Are we okay with that negative 1? Okay. So here I have negative 1. And then our last one, we need to plug in 1, negative 1. No, 1, negative 1. Too many ones. So we have 4 again. Cosine of pi. Is that again negative 4 again? Pretty steep. So then let's answer the next piece. Part B. Sullivan, let's read.
There is a horizontal line with equation y equals c that satisfies this differential equation. Find the value of c.
So we have a horizontal line, which is right here. So assuming they're all going in increments of 1, c is equal to what? 1, done. Now, part C is going to involve quite a bit of work. So try to write small if you can, and I will do my best as well. Let's start by writing out the equation. I'm going to write out dy over dx is equal to y minus 1 all squared cosine of pi x. So I need to go ahead and make sure all the dy's are on one side and dx's are on one side. So I'm going to move the dx over to this side, and I'm going to move this in front of dy. So let's start by writing it out 1 over y minus 1 all squared dy. Just reorganizing it. Cosine of pi x dx. So again, moving the dx to the other side and dividing by y minus 1 all squared.
Is that the same thing as putting dy?
On the bottom, yes. And then let's go ahead and rewrite this guy. Let's do the right side first. The right side is easier. On the right side, we're going to let u equal pi x. So we have u is equal to pi x. So du is equal to pi dx. So let's see if I'm satisfied. I have dx, but I do not have what? So I'm going to move it over. 1 over pi du is equal to dx. So completely ignore the left side. We're just integrating separately. So we're now looking at 1 over pi that I'm going to kick out. Integral of cosine u du. What is the integral of cosine?
Negative sign.
Ooh, native sign or sine?
Sign.
Sine, very good. And for sine u, to save room, let's go ahead and plug in pi x. And we're going to write plus c just one time. So the right side is done. Now let's worry about the left side. On my left side, I'm going to use this room over here. Y'all might not need it. I do. So we have y minus 1 to the negative half dy. And we're going to let u equal this guy right here. And du is equal to dy. And what's nice is, do I have what I want already on there? I don't need to kick out anything. So here I have u to the negative 2. We want to integrate it. And then we have du. What is one more of this guy? So negative 1. And then if I multiply or divide it by negative 1, isn't the value still the same? Yeah? If you want to write negative 1, you can on the bottom, but I'm just going to write negative right there. And then let's plug it back in. This right here is really going to give me negative 1 over u. They're identical. Now let's plug in this guy right here. So we really in the end have negative 1 over y minus 1. So I'm going to kind of go back to, if you were in my geometry class, we did something when we did unit 6. I'm going to give you a side note. Back a long time ago, when I had 2 over x is equal to 7, I taught y'all something with a variable on the bottom. If there is a variable on the bottom, what am I allowed to do? I can switch them. I'm going to use that method. And that method I'm going to use with the following. I'm going to switch these two, the whole thing. So everything on the bottom with everything on the other side. So when I do, I get negative 1 over all of that. It looks kind of fancy, but it's all about copying a lot of work, or the writing. So I have y minus 1. And then what's nice about this one is my goal is to solve for y. Am I already almost there? You just have to add 1. So we have y is equal to all that fraction that I'm going to try to squish it in. Good luck to you, or more of good luck to me. Plus 1. And then what's our problem from here? C. So here's my x, here's my y. So we have my y is equal to 0. Then let's plug in 1 for my x. 1 over pi, sine of pi, plus c. And don't forget that plus 1 at the very end. Let's see what we know about sine pi. At pi, what is my sine value? 0, so all that is gone, which is kind of nice. Oh, can I fit this? Are y'all okay if I move the 1 over first? Minus 1, negative 1 over c. So what is the value of c? When I swap these two, it gives me c is equal to negative 1 over 1, or negative 1, which is positive 1. So our final answer that I'm going to stem off of this one to write on this side is going to be y is equal to negative 1 all over 1 over pi sine of pi x, extend that, plus 1, and at the very end, plus 1. And let's see if I can highlight our final answer so y'all can see it. This is our particular solution.